class. So you have made it to semester test review time, and I'm going to work through most of the odds. I will do some evens, just depending on where the question is, and if we need to cover it, I'll do some evens, but mainly odds. This is a system of two equations with two unknown values in it, and we have to solve it using elimination or substitution. So we have to find the value for x that we could plug into both of these equations, along with some value of y that would satisfy both of them, that would make them both true. Since the first equation is already solved for y, this is set up very well for substitution. We'll do another one that is better suited for elimination, but right now this is set up very well for substitution. What the first equation is saying is that y and negative 6x minus 11, same thing. And so we can plug in negative 6x minus 11 for this y. So when we come to that y in the second equation, plus 4, we've arrived at the y. We're not going to put y, we're going to put negative 6x minus 11. I should have circled that in red. And it's equal to negative 2. Okay. Now it's just a single variable problem that we have to simplify. So 4 times negative 6 gives us negative 24, and those are x's. 4 times negative 11, negative 44 equals negative 2. So then we combine like terms on the left. Negative 21x minus 44 equals negative 2. We'll add 44 to both sides. Negative 21x equals 42. Then we divide by negative 21, and we find out what x is. Okay. So the x variable should be equal to negative 2. Not quite done though. We still need to find out what y is. And so we're going to use that top equation. Y is negative 6x minus 11. We're going to plug in that x value because now we know what it is. Y equals 12 minus 11, y equals 1. And the way we write our final solution is as an ordered pair, x, comma, y, because this in the red is the location on a graph where you would find these two lines intersecting one another. And let's scroll down and do another one. So number 3, whoa, there we go. Same goal in mind, but here neither x nor y is solved for, or by themselves, and so a lot of times in this format it's easier to do elimination. And in order to eliminate, you're trying to basically add all the x's, all the y's, and all the numbers in columns like you did old school with like 21 plus 14. You just added the columns. And the goal is that one of those columns will cancel each other out. But if you look, they're not going to because they're not the same numbers. So what we have to do is make this equation, at least one of these numbers needs to line up. If we multiply x by 3, then 3x plus negative 3x would be 0. And that's exactly what we're trying to do. So we multiply by 3. And now we multiply this by 3, we multiply that by 3, and we multiply that by 3. All of it has to be multiplied by 3. Even that number, the constant at the end. Then we'll put the other equation down here. 9y equals 4. And now we add. 3x plus negative 3x is no more x's. Negative 9y plus 9y is no more y's. Negative 6 plus 4 is negative 2. And so on the left, what do we have? We have no x's or no y's. We have nothing. And on the right, we have negative 2. And so what does that mean? Well, it means that we have a statement here that is not true. 0 equals negative 2. And that statement doesn't depend on x or y. In other words, y and x can't help this become true, which means that there is no solution to this system. these would be two parallel lines that just never cross. No solution. Now, had we gotten a true statement, which, spoiler alert, that is what you'll get on number 4. If you get a true statement, that means that there's an unlimited number of x and y pairs that you could get to solve that system because they're the same line. There's 1 and 3.